Hello everyone, I hope you are doing great. I am Bashar. Welcome to my channel Tech Quest Learning Point. In my last episode of this series, I discussed on the fundamentals of large-scale data warehousing. Today, I am going to discuss on fundamentals of real-time analytics. This tutorial is derived from Microsoft Learning Path that help you to make preparation of exam DP-900 Microsoft Azure Data Fundamentals certification. So I can assure that this tutorial will be helpful to clear the exam DP-900. Before starting the tutorial, let's see the content of this tutorial at a glance. In this tutorial, we will learn about the basics of stream processing and real-time analytics and services in Microsoft Azure Data you can use to implement real-time data processing solutions. This tutorial covers the various topics related to the fundamentals of real-time analytics, including batch and stream processing, elements of streaming data solutions, Azure Stream Analytics, Spark structured streaming on Azure, and Azure Synapse Data Explorer. We know that the data processing is nothing but a conversion of raw data to meaningful information through a process. These are two general ways to process data. Batch processing, in which multiple data records are collected and stored before being processed together in a single operation. Stream processing, in which a source of data is constantly monitored and processed in real time as new data events occur. Batch processing. In batch processing, newly arriving data elements are collected and stored, and the whole group is processed together as a batch. Exactly when each group is processed can be determined in a number of ways. For instance, you can process data based on a scheduled time interval, or it could be triggered when a certain amount of data has arrived, or as the result of some other event. Let's consider road traffic. Suppose you want to analyze road traffic by counting the number of cars on a stretch of the road. A batch processing approach to this would require that you collect the cars in a parking lot and then count them in a single operation while they are at rest. If the road is busy with a large number of cars driving along at frequent travel intervals, this approach may be impractical, and note that you don't get any results until you have parked a batch of cars and counted them. A real-world example of batch processing is a way that credit card companies handle billing. The customer doesn't receive a bill for each separate credit card purchase, but one monthly bill for all of that month's purchases. Advantages of batch processing include large volumes of data can be processed at a convenient time. It can be scheduled to run at a time when computers or systems might otherwise be idle, such as overnight or during off-peak hours. Disadvantages of batch processing include the timely delay between ingesting the data and getting the results. All of a batch job's input data must be ready before a batch can be processed. This means data must be carefully checked. Problems with data, errors and program crashes that occur during batch jobs bring the whole process to a halt. The input data must be carefully checked before the job can be run again. Even minor data errors can prevent a batch job from running. Stream processing. In stream processing, each new pitch of data is processed when it arrives. Unlike batch processing, there is no waiting until the next batch processing interval. Data is processed as individual units in real time rather than being processed a batch at a time. Stream data processing is beneficial in scenarios where new dynamic data is generated on a continual basis. For example, a better approach to our hypothetical car counting problem might be to apply a streaming approach by counting the cars in real time as they pass. In this approach, you don't need to wait until all of the cars have parked to start processing them, and you can aggregate the data over time intervals. For example, by counting the number of cars that pass each minute. Some real-world examples of streaming data include a financial institution tracks changes in the stock market in real time, computes value at risk, and automatically rebalances portfolios based on stock price movements. An online gaming company collects real-time data about play game interactions and feeds the data into its gaming platform. It then analyzes the data in real time, offers incentives and dynamic experiences to engage its players. A real estate website that tracks a subset of data from mobile devices and makes real-time property recommendations or properties to visit based on their geolocation. Apart from a way in which batch processing and stream processing handle data, there are other differences. Data scope. Batch processing can process all data in the dataset. Stream processing typically only has access to the most recent data received or within a rolling time window, the last 30 seconds for example. Data size. Batch processing is suitable for handling large datasets efficiently. Stream processing is intended for individual records or micro batches consisting of few records. Performance. Latency is the time taken for the data to be received and processed. The latency for batch processing is typically a few hours. Stream processing typically occurs immediately with latency in the order of seconds or milliseconds. Analysis. You typically use batch processing to perform complex analytics. Stream processing is used for simple response functions, aggregates, or calculations such as rolling averages. Many large-scale analytics solutions include a mix of batch and streaming processing, enabling both historical and real-time data analysis. Look into the diagram. This diagram shows some ways in which batch and stream processing can be combined in a large-scale data analytics architecture. Number 1. Data events from a streaming data source are captured in real time. 2. Data from other sources is ingested into a data store, often a data lake, for batch processing. 3. If real-time analytics is not required, the captured streaming data is written to the data store for subsequent batch processing. 4. When real-time analytics is required, a stream processing technology is used to prepare the streaming data for real-time analysis or visualization, often by filtering or aggregating the data over temporal windows. 5. The non-streaming data is periodically batch processed to prepare it for analysis, and the results are persisted in an analytical data store, often referred to as a data warehouse, for historical analysis. 6. The results of stream processing may also be considered in the analytical data store to support historical analysis. 7. Analytical and visualization tools are used to present and explore the real-time and historical data. There are many technologies that you can use to implement a stream processing solution, but while specific implementation details may vary, there are common elements to most streaming architectures. Look into the diagram. This diagram shows a high-level architecture for stream processing. Number 1. An event generates some data. This might be a single being emitted by a sensor, a social media message being posted, a log file entry being written, or any other occurrence that results in some digital data. 2. The generated data is captured in a streaming source of processing. In simple cases, the source may be a folder in a cloud data store or a table in database. In more robust streaming solutions, the source may be a queue that encapsulates logic to ensure that event data is processed in order and that each event is processed only once. 3. The event data is processed, often by a perpetual query that operates on the event data to select data for specific types of events, projects data values, or aggregate data values over temporal time-based period or windows, for example, by counting the number of sensor emissions per minute. 4. The results of the stream processing operation are written to an output or sink, which may be a file, a database table, a real-time visual dashboard, or another queue for further processing by a subsequent downstream query. Microsoft Azure supports multiple technologies that you can use to implement real-time analytics of streaming data, including Azure Stream Analytics, a platform as a service PaaS solution that you can use to define streaming jobs that ingest data from a streaming source, apply a perpetual query, and write the results to an output. Spark Structured Streaming, an open source library that enables you to develop complex streaming solutions on Apache Spark based services, including Azure Synapse Analytics, Azure Databricks, and Azure HD Insight. Azure Data Explorer, a high-performance database and analytics service that is optimized for ingesting and querying batch or streaming data with a time series element and which can be used as a standalone Azure service or as an Azure Synapse Data Explorer runtime in an Azure Synapse Analytics workspace. The following services are commonly used to ingest data for stream processing on Azure. Azure Event Hubs, a data ingestion service that you can use to manage queues of event data, ensuring that each event is processed in order to exactly once. Azure IoT Hub, a data ingestion service that is similar to Azure Event Hubs but which is optimized for managing event data from Internet of Things IoT devices. Azure Data Lake Store Gen 2, a highly scalable storage service that is often used in batch processing scenarios but which can also be used as a source of streaming data. Apache Kafka, an open source data ingestion solution that is commonly used together with Apache Spark. You can use Azure HD Insight to create a Kafka cluster. The output from stream processing is often sent to the following services. Azure Event Hubs used to queue the processed data for further downstream processing. Azure Data Lake Store Gen 2 or Azure Blob Storage used to persist the processed results as a file. Azure SQL Database or Azure Synapse Analytics or Azure Databricks used to persist the processed results in a database table for querying and analysis. Microsoft Power BI used to generate real-time data visualizations in reports and dashboards. Azure Stream Analytics is a service for a complex event processing and analysis of streaming data. Stream Analytics is used to ingest data from an input such as an Azure Event Hub, Azure IoT Hub, or Azure Storage Blob container. Process the data by using a query to select, project, and aggregate data value. Write the results to an output such as Azure Data Lake Gen 2, Azure SQL Database, Azure Synapse Analytics, Azure Functions, Azure Event Hub, Microsoft Power BI, or others. Once started, a Stream Analytics query will run perpetually, processing new data as it arrives in the input and storing results in the output. Azure Stream Analytics is a great technology choice when you need to continually capture data from a streaming source, filter or aggregate it, and send the results to a data store or downstream process for analysis and reporting. Apache Spark. Apache Spark is a distributed processing framework for large-scale data analytics. You can use Spark on Microsoft Azure in the following services: Azure Synapse Analytics, Azure Databricks, Azure HD Insight. Spark can be used to run code usually written in Python, Scala, or Java in parallel across multiple cluster nodes, enabling it to process very large volumes of data efficiently. Spark can be used for both batch processing and stream processing. Spark Structured Streaming. To process streaming data on Spark, you can use the Spark Structured Streaming library, which provides an application programming interface API for ingesting, processing, and outputting results from perpetual streams of data. Spark Structured Streaming is built on a ubiquitous structure in Spark called a data frame, which encapsulates a table of data. You use the Spark Structured Streaming API to read data from a real-time data source, such as a Kafka hub, a file store, or a network port, into a boundless data frame that is continually populated with new data from the stream. You then define a query on the data frame that selects, projects, or aggregates the data, often in temporal windows. The results of query generate another data frame, which can be persisted for analysis or further processing. Spark Structured Streaming is a great choice for real-time analytics when you need to incorporate streaming data into a Spark-based data lake or analytical data store. Delta Lake. Delta Lake is an open source storage layer that adds support for transactional consistency, schema enforcement, and other common data warehousing features to data lake storage. It also unifies storage for streaming and batch data and can be used in Spark to define relational tables for both batch and stream processing. When used for stream processing, a Delta Lake table can be used as a streaming source for queries against real-time data, or as a sink to which a stream of data is written. The Spark runtimes in Azure Synapse Analytics and Azure Databricks include support for Delta Lake. Delta Lake combined with Spark structured streaming is a good solution when you need to abstract, batch, and stream processed data in a data lake behind a relational schema for SQL-based querying and analysis. Data Explorer. Azure Data Explorer is a standalone Azure service for efficiently analyzing data. You can use the service as the output for analyzing large volumes of diverse data from data sources such as websites, applications, IoT devices, and more. For example, by outputting Azure System Analytics logs to Azure Data Explorer, you can complement Stream Analytics low latency alerts handling with Data Explorer's deep investigation capabilities. The service is also encapsulated as a runtime in Azure Synapse Analytics, where it is referred to as Azure Synapse Data Explorer, enabling you to build and manage analytical solutions that combine SQL, Spark, and Data Explorer analytics in a single workspace. Data is ingested into Data Explorer through one or more connectors or by writing a minimal amount of code. This enables you to quickly ingest data from a wide variety of data sources, including both static and streaming sources. Data Explorer supports batching and streaming in near real time to optimize data ingestion. The ingested data is stored in tables in a Data Explorer database, where automatic indexing enables high-performance queries. Azure Data Explorer is a great choice of technology when you need to capture and analyze real-time or batch data that includes a time series element such as log telemetry or values emitted by Internet of Things IoT devices. Explore, filter, and aggregate data quickly by using the intuitive and powerful Costo query language KQL. Azure Synapse Data Explorer is an especially good choice when you need to perform this task in a centralized environment used for other kinds of analytics such as SQL and Spark-based queries. Review. Batch processing. In batch processing, newly arriving data elements are collected and stored, and the whole group is processed together as a batch. Stream processing. In stream processing, each new piece of data is processed when it arrives. Unlike batch processing, there is no waiting until the next batch processing interval. Data is processed as individual units in real time rather than being processed a batch at a time. Stream Analytics. Azure Stream Analytics is a great technology choice when you need to continually capture data from a streaming source, filter or aggregate it, and send the results to a data store or downstream process for analysis and reporting. Apache Spark. Apache Spark is a distributed processing framework for large-scale data analytics. Spark structured streaming. To process streaming data on Spark, you can use the Spark Structured Streaming Library, which provides an application programming interface API for ingesting, processing, and outputting results from perpetual streams of data. Delta Lake. Delta Lake is an open source storage layer that adds support for transactional consistency, schema enforcement, and other common data warehousing features to data lake storage. Data Explorer. Azure Data Explorer is a standalone Azure service for efficiently analyzing data. You can use the service as the output for analyzing large volumes of diverse data from data sources such as websites, applications, IoT devices, and more. Thank you for watching this tutorial. I hope you all have been able to take the idea about the fundamentals of real-time analytics. If you think this tutorial is helpful for learning the Azure Cloud Computing, please click on the like button and request you all to share it more and more to the persons who are searching the tutorials like this. If you have any questions on this tutorial, opinions and queries about this channel, please type this in the comment box. You also mail to me in the description box. Email ID is given for you. Kindly subscribe this channel and click on the bell button so that you can get notification when tutorial is published.